static friction. Introduction. A force opposing relative motion or its tendency between two bodies in contact is called the force of friction. It acts along the surfaces of contact of the two bodies. The force of friction present when one body is about to move with respect to another body in contact is called static frictional force. The maximum value of static frictional force is called the limiting static frictional force. The coefficient of static friction, that is, mu s, between two surfaces is defined as the ratio of the magnitudes of the limiting static frictional force Fs and the normal reaction N. Therefore, mu s is equal to Fs upon N. In the case of the motion of a body of mass m along a horizontal plane, Fs is equal to P, minimum effort needed to start the motion of the body, and the normal reaction. N is equal to mg. Therefore, mu s is equal to P upon mg. Aim: to study the relationship between the limiting force of static friction and normal reaction for a block on a horizontal surface and to determine the coefficient of static friction. Apparatus: a plane surface, a rectangular wooden block with a hook, a string, a pan, a weight box, a meter scale, a spirit level, and a balance. Procedure: let us first determine the mass of the wooden block and the pan separately using the balance. Record them as observations. 1. The mass of the block W0 is equal to 92 gram. And 2. The mass of the pan P0 is equal to 20 gram. Level the plane surface using the spirit level such that the air bubble in the spirit level remains at the center when the spirit level is kept on the base at various places. Keep the block on plane surface. Tie one end of the string to the block. Mark the position of the block. Pass the string over the pulley and tie its free end to the pan. Adjust the pulley so that the string is horizontal, that is parallel to the plane. See that the string passes over the groove of the pulley and that the pan does not touch the table. In the first observation, let there be no weight placed on the block. Hence, write 0 in the column weight on the block W. The total load W is equal to W0 plus W is equal to 92 plus 0 is equal to 92 gram weight. Write in the respective column. Now let us add a small weight to the pan and observe whether the block is moving. It is not moving because the applied force tending to move the block is balanced by equal but opposite frictional force. Now add slowly some more weights in the pan till the block just begins to move. As the weight in the pan is increased, the frictional force between the contact surfaces also increases. When it reaches its maximum or limiting value, it does not increases further with increase in weights in the pan. The block starts moving. Hence, the force exerted on the block by weight in the pan when the block just starts to move is equal to the limiting frictional force. Note the weights added to the pan. It is 17 gram. Record it in the column weight added to the pan P in gram weight in the observation table. Now, to find the total force exerted on block or effort P, add weight of the pan P0 and weights added to the pan P. That is, P is equal to 20 plus 17 is equal to 37 gram weight. Now, place some weight on the block and repeat the procedure to find minimum value of the weight to be added to the pan so that the block just starts moving. The initial position of the block on the plane should be the same in all the cases. Calculate the coefficient of static friction using equation mu s is equal to P upon W in each case. Hence, find mean value of static friction mu s. It is found to be 0.40. Let us plot a graph of the effort P versus the total load W. It is straight line. The slope of the line is the coefficient of static friction mu s. Hence, slope is equal to mu s is equal to BC upon AC is equal to 100 minus 60 upon 250 minus 150 is equal to 40 upon 100 is equal to 0.40. Let us write our results. Coefficient of static friction mu s 1 is equal to 0.40 by calculation. 2 is equal to 0.40 from the graph. Notes and precautions. 1. The string tied to the block should be parallel to the plane on which the block is kept. 2. The initial position of the block on the plane should be the same in all the cases. 3. The surfaces of the block and plane in contact should be clean and dry.